So we're given this graph of y equals g of x, and we are assuming that it continues infinitely beyond the given frame. So arrows here heading up to infinity, arrows there heading up to infinity. So the first question asks us, what is the domain? So can we express the domain of this? What are all of the x values that I see here? Well, this gets very, very large. So it's heading up and heading to the left. This gets very large, heading up and to the right. The domain here is going to be all real numbers. So if I use interval notation, how do I do that? We're going to go ahead and we're going to write it as negative infinity to positive infinity. So let's see, where is the infinity button? Negative infinity, inside the parentheses. Negative infinity to positive infinity would be our domain. So that's what we have there. Now, how about the range? The range, what are the y values? How low does it go? Well, according to this, my lowest y value is negative 5.75. And I'm going to make that a square bracket because it actually gets there. And how high does it go? How high does it go? Well, it goes as high as you want, right? Because it continues infinitely beyond the frame. So the range would be from negative 5.75 to infinity. So let's go ahead and put that in. So indeed, from negative 5.75 to infinity. Notice negative 5.75 is a square bracket because we actually get there. Infinity is a round bracket because we never actually get there. Now, where is this thing increasing? Where is this thing increasing for what values? So you think of the x value as time, and you think of the y value as height. So we ask, at what time is it rising? So it starts rising here at negative 2. It stops rising at 1, and then it starts falling again. Then it starts rising at 5 and beyond. So from negative 2 to 1 is part of it. That's one place where it's rising. So from negative 2 to 1, we have that. And again, I prefer to use round brackets for that, for increasing. Together with what? Together with from 5 to infinity. Remember, this keeps growing forever. So we'll go ahead and put in the union 5 to infinity. And we have, that is the interval where it is increasing. Again, negative 2 to 1, x values from negative 2 to 1, it's rising. X values from 5 to infinity, it's rising. Now, where is it decreasing? Where is it falling? It's falling here, and it's falling here. So it's falling from negative infinity to negative 2, and it's falling from 1 to 5. So let's put that down there. So what are we going to say? Again, falling, x value is negative infinity to negative 2. Negative infinity to negative 2, union, where else is it falling? Oops, I guess I went too far. There we go, there's my union. Union what? Union from 1 to 5. X value from 1 to 5, time 1 to time 5, it is falling. And then the last question we need, let me shrink this so I can actually see the question. It achieves an absolute max of what? Absolute minimum. What is the lowest value I ever see? Lowest value I ever see, negative 5.75. Where? At x equals 5. How about an absolute maximum? When does it reach its absolute highest point? Well, you think it might be here, but no. It grows beyond there and there. So this has no maximum. There is no absolute maximum. Now, a local minimum, I have 2 of them. Okay, so we have 2 of them. I have a local minimum of negative. So let me copy this. Actually have two local minimums. So G part 2. One of the local minimums is negative 2.32. And where does that local minimum happen? At x equals negative 2. We have another local minimum of negative 5.75. So can it be both an absolute and a local? Yes, it can. A local minimum of negative 5.75, where at x equals 5. And then the last question is, what is achievable local maximum, right? Local maximum is here. Local maximum in the neighborhood, that's the biggest local maximum of 0.65. Where does that occur at? The local maximum of 0.65 occurs at x equals 1.